All right, time for some questions. So this first one in the set has asked us to sketch the graph of y equals 2 over x plus 1 minus 3. So the first thing I'm going to do is identify the transformations that have occurred to it. So I notice that this h value here is 1. I notice the k value is minus 3. So I'll just interpret those. This means 3 units down. And keeping in mind that the h value was already negative inside the hyperbola, I have to read the opposite of this. So this means 1 unit left. This a value is the dilation factor, and it means that each point has moved 2 times further away from where it was in the original. So now it comes time to graph. So first things first, I'm going to use this information to put in my asymptotes. So 1 unit left, I'll say is there. I draw in a dotted line to show the asymptote. All right, and I can label it as x equals minus 1. The vertical asymptote is, the horizontal asymptote is 3 units down. So 1, 2, 3, and I can put in my dotted line there. All right, and I can label it. This should be y equals minus 3. All right, from this point, don't be tempted to sketch your graph just yet. What you're going to want to do is find out the x and y intercepts, in case there are any. All right, now you notice that in this top right quadrant here, you can see that the asymptotes mean that the hyperbola is going to go through both the x and y intercepts up here, but this bottom left quadrant, it's not going to go through either of them. So keep that in mind as you solve, and what you'll need to do is make sure that your answers reflect that property. So the first one, the y-intercept, we know that we can find the y-intercept by finding when x equals 0. So we just plug in 2 over 0 plus 1 minus 3, which is equal to 2 over 1 plus 3, which is equal to, minus 3. 2 over 1 minus 3, change colour, minus 3, which is equal to minus 1. So the y-intercept is at minus 1, and we'll mark that point on the graph there. All right, the second point is to find the x-intercept, and we do that by finding out where y equals 0. So same way, just substitute y equals 0 in, x plus 1 minus 3, move the 3 across, 3 equals 2 over x plus 1. Don't be tempted to, I'm going to multiply the whole of the denominator across, so that will lead to 3 bracket x plus 1 equals 2. Don't be tempted to expand the brackets, just divide by 3, and that's going to give you x plus 1 equals 2/3. Move the 1 back across as a negative, and you end up with minus 1/3 as the x-intercept. And we'll put that point on there. Not very good graph. All right, now you've got 2 points in this top right quadrant, and you can see here that the parabola is, the hyperbola, I keep saying that, is going to look something like that. In the bottom left quadrant, it's not going to hit either axes. So you're just going to draw in a curve like that. All right. You can label these points here. What was it? Minus 3rd comma 0, minus 1, 0 comma minus 1, like that. All right. Make sure you cap your lines with arrows. Make sure you label points. Make sure you label your asymptotes. And it's probably pretty good practice to develop to write in the rule of the function you've just graphed as well. All right, so to recap, we can first of all read translations that have happened off the formula for a hyperbola. Then we need to graph the asymptotes using the knowledge of those translations. If possible, we need to find axis intercepts and or any other points that we might want on the graph. We need to plot them and then join them up with the curve to show the hyperbola. All right. Lastly, we need to make sure we've labeled all important information, which is asymptotes, points, and function. All right, another example we're going to go through and quickly sketch. So this is the rule that's been given to us. It's minus 2 over x minus 1, and we've been asked to sketch it. So straight away, what comes to mind from me is the fact that there is a negative on the numerator. So this negative means that there is some reflection. All right. Now, reflection for hyperbolas are both the same. So I'll demonstrate why. If this is the original hyperbola and I reflect it across the y-axis, this is going to look like this, and this one is going to look like that. So you can see that that happens there. Now if I reflect this line across the x-axis, it's going to look like that, which is the same as, and this one is going to look like that, which is the same as the original one. So reflections in hyperbolas are all the same. You don't have to worry about which way it reflects. You just have to know that it's reflected and it's no longer in the top right and the bottom left quadrant. It's been reflected to the other one. All right, so I'll redraw my coordinate graph. So first of all, I want to find out, I actually want to read the transformations that have happened off the equation. So first of all, there's been a reflection, which means it's now in this quadrant and this quadrant instead of the first and third. And there's also been a 1 unit shift horizontally. Now remember that that negative sign is embedded in there, so I have to read that as the opposite. So it's been shifted 1 unit right. All right, so that means I can graph the vertical asymptote here, 1 unit right as a dotted line. I can call it x equals 1. Now notice that there is no k value. This means there is no vertical translation, which means that the asymptote sits directly on the x-axis. All right, so I'll graph it as a different color. Okay, so we can see here that there is an asymptote on the x-axis at y equals 0. All right, now looking at the information we've got before us, we know that it's going to be in this quadrant and this quadrant. We know that because there's been a horizontal shift to the right, that it's going to go through the y-axis in this top right quadrant here. We can see in this top left quadrant, in this bottom right quadrant, you can see that there are no axis intercepts because it approaches the x-axis but never crosses, and the y-axis is not even in this area here to go over. So that should give us some clues. So the next thing we're going to do is find out where the y-axis intercept is, and we do that by setting it equal to 0. Setting x equal to 0. Minus 2 over 0 minus 1, which is equal to minus 2 over minus 1, which is equal to 2. So we can graph this point here as 2. We'll graph it as 0 plus 2. All right. Now just to illustrate the fact that there are no x-axis intercepts, we'll set y equal to 0 and we'll see what happens. X minus 1. If I multiply this across to the other side, I get 0 bracket x minus 1 equals minus 2. If I divided by 0, which I'm not allowed to do, I would see that x minus 1 equals undefined. Minus 2 divided by 0 is undefined. So there is no way I can go past this last step here to find an x-axis intercept. So that should be our clue. If we come across something like this with an undefined value in it, we should always look back at the graph and think to ourselves, does it actually go across the x or the y intercept, whatever the one we're trying to find is. All right, so armed with the y-intercept and the reflection, we're just going to do a quick sketch. We know that it goes in this top left quadrant here. It goes through that. We'll draw the arrows on there. It goes through at the y-intercept we found, and we know that it goes in this bottom right quadrant as well. All right, we don't know any other points on it. We could find one if we wanted to. If you felt like subbing a point in this bottom right quadrant in, you could do that. But a quick sketch like I've just done is enough at this point, unless the question deliberately asks you to label a third point or another point in the bottom right quadrant. So this final picture here is the sketch of the hyperbola. Let's just double check we've done everything. We've found and labeled the y-intercept. We've found and labeled the asymptotes. We haven't labeled the function, so we'll do that now. X minus 1, and there we are. We're all done. This graph here is labeled clearly for everyone to see and understand what we were sketching.